Speaker is an engineer from MIT. He was going to be the energy secretary of Venezuela with the presidential candidate who was running against Hugo Chavez. That's actually not what Jose said. He said that criminal, assassin, communist, totalitarian dictator Hugo Chavez. So he's not a big fan. Because of that, he had to leave Venezuela for political exile in Japan and had to change his citizenship to an EU passport. He now lives in Korea in what he calls the most advanced city in this corner of the universe. I'll let him explain a little bit more about that. He's a teaching fellow at Singularity University, a great friend of the transhumanist movement all over the world, and is actually, now that I think about it, is the first person who told me about the transhumanist movement that was out there and that I could get involved. So there you go. Please welcome Jose Luis Cordeiro.
Good. So good afternoon to everybody. It's a pleasure for me to be invited by the Singularity Institute, Michael Bassar, and all the friends here of this movement. I have been working for 10 years with the Millennium Project that began in 1996 as the futuristic part of the United Nations at the time. It started under the American Council of the United Nations University, and we have been doing work about all the futuristic issues. And one of those issues is energy. Actually, I have been personally working in the energy industry since I graduated from MIT for 25 years. And energy is the largest industry in the world. Energy is $8 trillion every year. So it is interesting to talk about robotics, to talk about nanotechnology, to talk about biotechnology, but that is nothing compared to energy. This is the industry that rules the world, and without energy we could do nothing else. So basically, the Millennium Project, we publish every year one report about the state of the future. I have a copy here for if anyone is really dying to read this, which is a fantastic book recommended by Ban Ki-moon, Secretary General of the United Nations. And we make forecasts on different areas. And as I said, I have been working for the Millennium Project in the energy area for many years in the Middle East, in Asia, in Latin America. We have nodes all over the world. And we basically are futurists. Futurists are people who think about the future and who design strategies towards the future. There are 4 ways to think about the future. The worst one is to be an ostrich, a passive person that only responds when something is happening, and you don't even want to get your head out of the ground. It is a little bit better to be reactive, like a firefighter, to respond to the changes. But even better is to be proactive, like when you buy insurance. But the best way is to be proactive, to create the future that you want. So I hope that we do not have any ostriches here. But if we have ostriches, at least you should be using technology. We should have some technological ostriches here. As it was mentioned, I have been a teaching fellow in Singularity University since it began last year, officially in the summer. And some of our students are here, some of our associate founders as well. And even though I love areas like medicine, neuroscience, and human enhancement, and artificial intelligence and robotics, my main area of expertise is energy. And so I'm coordinating with the students the Home Energy Generation Team Project at Singularity University. And our objective is to impact positively in the life of 1 billion people during the next 10 years. For the opening session, we had Larry Page. And Larry Page said, if I was a student, this is where I would want to be, at Singularity University. Actually, many people from Stanford got very upset at him, very mad, but anyway, so this is some of the things that we're trying to do at Singularity University. In fact, the co-founder of Singularity University, Ray Kurzweil, is working with Larry Page in the #1 engineering challenge of the future. These were decided by the National Academy of Engineering, and Larry Page and Ray Kurzweil have been working on this. How to make solar energy economical for humanity. Actually, if you look at the energy sources that we have readily available for humanity, you can see that the big elephant is solar energy. We have, on the surface of our planet, basically a huge amount of energy, enough to power human civilization many thousand times over, many thousand times over. And then we have wind and some other sources of energy. In 2010, this year, humanity is going to be using the equivalent of about 16 terawatts of power. But obviously, the fuels we have been using up to now are basically fossil fuels based on dinosaurs or whatever 200 million years ago. And we are going to reach a peak, which is sometimes referred to as peak oil. My dear friend Ramesh Nam was talking about this, about peak oil. But actually, Sheikh Ahmed Yamani, who was one of the most important people in the energy industry, he was Minister of Energy of Saudi Arabia and head of OPEC, he said that the Stone Age did not end because of lack of stones. And the oil age will end soon, and not because of lack of oil. So this is very interesting that someone from Saudi Arabia, the largest oil-producing nation in the world, sees that the end of oil is finishing in the next 20 years. For those who are worried about peak oil, because it will probably happen, but my question is it important? And I will say, no, it is not important. If it happens, when it happens, it is irrelevant. Actually, in the 19th century, we had another peak. It was called peak well oil. You know, we were actually going through a crisis in the 19th century because there were not enough wells to produce the oil we needed for our lanterns at the time. So thanks to technological change, things change very rapidly. Also, talking about the situation of global warming, there are so many factors involved in global warming, like the activity of the sun. Also, there have been many studies of this. So now that we had the Mars rovers on Mars, they had temperature sensors. And during the time that those sensors were working, it was truly fascinating to know that there was a 90% correlation between the temperature of Mars and the temperature on our planet Earth. And as you probably know, there are no Martians that we know of. And there are no fossil fuels on Mars either. However, there was an incredibly high correlation. My point, however, is not to say that there is not a global warming, or as they call it now, climate change. Because when I was a kid, actually, I remember the crisis was global cooling. In the 60s and 70s, the problem of humanity was global cooling. But I do want to say that apparently there is global warming, and this is the final proof, in case that you haven't seen it. How bathing suits have been changing through time and what we use today. When I went to MIT, I became involved in all these futuristic ideas because the Club of Rome had just published a report that was basically done at MIT by the father of system dynamics, Professor Jay Forrester of mechanical engineering at MIT. And he had access to computers, and he made the first simulation about the future of humanity. So this report had an incredible impact. Sadly, it was terribly wrong, because it did not account for technological change. And it has been technology that has improved the situation of humanity. A few years after this report was released, another very famous futurist, Herman Kahn, published another book to celebrate the bicentennial of the US independence in 1976. And in this report, actually, basically, he destroyed all the theories of the Club of Rome, and basically, the changes are due to technological advances. Some companies like Shell, you probably are familiar with people also at the Long Now Foundation, Peter Schwartz, and former Shell employees that have been working with scenarios for a long time to see where humanity is going. And this started actually in the oil industries in the 1970s. And Shell was probably the first company that used this successfully. And they were ready for the oil shock, the Arab oil shock in 1972 and 1973. Since that time, many studies about the future of energy have been done, I would say, scientifically. Now Shell also has their sustainable growth scenarios, and this is a very interesting chart where they even have, by the year 2050 to 2060, something called surprise energy. So no one knows what this surprise energy is, not even Shell. But new sources of energy are coming very, very fast, as we will see. In fact, also there is plenty of oil, plenty of oil. The country where I was born, Venezuela, actually has oil for about 4 centuries, for 400 years. And this is If we include also the heavy oils, or the Canadians, if you include what, all the oil sands in Alberta and in the USA also, we have really oil for maybe 200-300 years. But again, the problem with oil is that it is dirty. It is not a clean fuel, and we have better sources of clean energy, like solar energy. We can go deeper and deeper. This is not an issue. When I began working in the oil industry, actually, all the wells were vertical and basically on land. Now, all the wells are actually horizontal, and they go offshore at incredible depths. But we have seen different energy waves. The first energy source that we used for a long time, humanity, was lumber, trees, wood. And you can see in the 17th, 18th, 19th century, it was basically lumber. Then coal was used industrially. Then we had another wave, which was oil. Now we're another wave, which is the gas wave. What is interesting is that each one of these waves uses less carbon, and it has more hydrogen. So basically, we are decarbonizing energy, or we are hydrogenizing energy. We are moving from dirtier fuels based on carbon to cleaner fuels based on hydrogen, which is the ultimate source of energy of the universe. It is hydrogen that powers the universe, fusion of hydrogen. At the end, this is an economic problem. It's energy return on energy invested, and there are many considerations from the economic point of view. Many universities like MIT has a very important energy initiative to see what is happening. And not only educational institutions like MIT, but also big companies like BP. And we all know the disaster happening with BP. They came from British Petroleum to Beyond Petroleum to back to petroleum. And the situation is, in the Gulf of Mexico, very sad. But anyway, this is still the largest industry in the planet. But things are changing, and they are changing fast. There have been many people talking about energy issues for a long time. One of the most famous futurists, Buckminster Fuller, he talked about creating a global energy network that would connect the whole planet. And actually, we are still far away from that, but this is becoming a real possibility now. And also with Wi-Tricity, wireless electric transmission, that was also started at MIT 3 years ago. This is one of the most incredible things. Just like we have mobile telephones now for telecommunications without wires, we will soon have also wireless electric transmission. I had the pleasure to meet Sir Arthur C. Clarke, who is so famous among all the futurists and science fiction fans because of his laws of the future. And he believed in all these technologies. And he had these 3 famous laws of the future. The third one, which is one of my favorites, any sufficiently advanced technology is indistinguishable from magic. He was a very close friend of James Randi, who will be speaking soon. They were very good friends, and they had fantastic jokes, and they were also great scientists and magicians. And so we will move soon from Sir Arthur C. Clarke to James Randi. But Sir Arthur C. Clarke believed also on space elevators that will help civilization to move out of our cradle planet, to go from planet Earth onto space. So technologies have changed radically during the last 30 years, and they will change even more radically during the next 30 years. We'll probably see in 30 years ageless cells. We will have basically free energy, and we will have space elevators in the next 30 years. Bob Metcalfe, one of our faculty at Singularity University and the father of Ethernet, and he talks about this new concept of the energy internet based on his experience with Ethernet. And we are moving then from this world of dirty energy into clean energy, dumb grid to smart grid, inefficient system to efficient systems, expensive to cheap energy, centralized to decentralized, low to high redundancy, from fossil fuels to renewable energy sources, from producers to prosumers, producers and consumers of energy, and from the big oil utilities to something which is quite interesting, which is we have entrepreneurs in energy, and we have venture capital in energy for the last 10 years. And this is something very important, because if there is venture capital in an industry, it's because something good is going to happen. And this is the first time in the last 10 years. We have had a lot of venture capital in IT and then in biotech, but now it is in energy. And remember, this is not just any industry. This is the largest industry in the world, $8 trillion. We have also bioenergy. Craig Venter is working on his artificial bacteria to produce biofuels, to produce gasoline. And these bacteria, I had the pleasure to be talking to him, and he explained to me what he's doing. These bacteria are going to be so incredible that they are going to eat the bad gas, the carbon dioxide. For those of you worried about carbon dioxide, well, these bacteria will eat carbon dioxide. They will drink water, and then they will excrete gasoline of 99 octanes. These bacteria are really, really incredible. They are so incredible that the largest company in the USA, energy, ExxonMobil, they decided to give him $500 million. Remember, this is a big industry, so $1 billion, $500 million. And we will soon move from this world of the fossil fuels to the live carbohydrates. And if you actually hear carbohydrates, hydrocarbons, don't they sound terribly close? They both have hydrogen and carbon. Okay, there are many types of energy, but what I want to emphasize with this is that we have been using actually very low intensity energy sources. The energy content of the sources we use today is pretty bad. It's basically in the range of 20 to about 40 megajoules per kilogram of matter. So these energy sources we are using today are really bad. We are soon moving into new sources of energy which are much more energy intensive with a higher density until we get to the mass energy equivalence that everybody knows, Einstein's equation, mass into energy, which will give us truly almost unlimited amounts of energy. And we can go one step further to go from matter into antimatter or antimatter into matter, supposing that this is possible. But in any event, the point is that there are incredible amounts of energy that we have not tapped yet. Tomorrow, I will be leading a tour at the National Ignition Facility to see what is happening in nuclear fusion. There are 2 experiments in the world for nuclear fusion. One is done in France, which is just beginning, ITER, which is at Tokamak, and this one in near here in Livermore, Lawrence Livermore National Laboratory, the National Ignition Facility. This is an incredible opportunity to create nuclear fusion. They might be 10 years away, 20 years away, we don't know, but the fact is that it is already possible. They produce energy. The only problem is that it is not economic. They have to put $4 for every dollar they get on return on energy. So actually, this is like the most expensive energy that you can see today, because for 1 nanosecond, they have to pay $1 billion. So they don't run this experiment very often. However, this is a matter of time until we are able to move and control this process in a better way, because it is done. The sun, which is not intelligent, does it. So why, if we are intelligent, we cannot do it and better? So talking about, so how much energy is there in the universe? How many of you have heard of Nikolai Kardashev? If you can raise your hands, Nikolai Kardashev. Okay, about 15 people, that's not too many. Anyway, Nikolai Kardashev is a Russian astrophysicist who is still alive, who devised the energy scale of the universe. Basically, his scale is an exponential scale. All of this is exponential. And he defined a civilization type 1 as a civilization that uses all the energy available to its planet. Actually, humanity today is not even at 0.07 Kardashev scale. So we are really nothing in terms of energy available that we have, 0.7 Kardashev scale. But actually, there are things which are even less than us. You know, if you see one of these quartz wristwatch like this, basically this is 1 microwatt. If you have a CD-ROM laser, that is about 5 milliwatts. A human brain is about 30 watts. A human body is about 100 watts. There are some who are fatter and maybe require more than 100 watts, but on average it is about 100 watts. The whole human civilization today is using about 16 terawatts of energy. That would make us, well, that is what it is today. But the potential we have on our planet is 174 petawatts. So just to put it in numbers, in 3 ways so that you will not forget. If we only used 1% of the solar energy that reaches our atmosphere, we solve all human problems today. With 1% of 1%. I'll say it in 2 other ways. In 1 hour, we receive as much energy as we use in 1 whole year. In other words, we receive 10,000 times more energy than we use today. So do you think that there is an energy crisis? Do you think that there is peak oil or peak well oil? No, it's that we don't know how to use these incredible amounts of energy that we have available to us. So I'm proposing a new word, the energy singularity. As we have people who talk about the technological singularity, and people like Aubrey de Grey that in a previous Singularity Summit, he talked about the Methuselarity. So I propose that we begin using the energularity, which is this point when, maybe a human civilization will reach Kardashev scale 1 and will allow us to leave this planet to colonize the rest of the universe. If you look at the growth of the solar power, it's absolutely exponential. The energy industry is growing exponentially. The costs are reducing exponentially. Actually, look at this from an MIT professor called Emanuel Sachs. This is like the Moore's law of solar energy. Look at how this is an exponential scale on the vertical axis, and on the horizontal axis actually is the cumulative production. This is beautifully exponential. And there are many types of solar energy. We don't have to use just one. If we had just a few places like this, about 100 kilometers on each side on different parts of the world, we could power with solar technology today humanity. So this is not truly complicated. We can do it if we take the political decisions as well. NASA had a program for space solar power that unfortunately was stopped in the year 2002. That would have been fantastic. It could have been, solar panels orbiting the Earth. We would be using this to go outside our planet, but Japan has retaken this project. Actually, the objective now in Japan is that by the year 2030, they will be powering Tokyo with a space-based solar power. I lived 3 years in Japan, and this is one of the most fantastic things happening in Japan, using solar power from space, a space-based solar power. We can also use the moon. There are many other possibilities. So just let me go quickly to finish into energy and geopolitics, because this is truly not only the largest industry in the world, but it is also very complicated because of geopolitics. And there are many crazy people, like Castro, Chavez, OPEC, and different groups working on these issues. And it is very complicated. In case that you didn't know, here there is a cartoon about the oil industry. We shall not exonerate Saddam Hussein for his actions. We will mobilize to meet his threat to the vital interest in the Persian Gulf until an amicable solution is reached. Our best strategy is to be prepared. Failing that, we are coming to kick your ass. Okay, so this is really a global industry, very big, very powerful. I don't have to convince you of that, as you probably know. And this is also, a friend of mine sent me this very interesting painting of, the American world. And the important part I just wanted to emphasize, this is called oil and war. Oil and war. Okay, so we need cheap energy to solve all the problems of humanity. And we are going to have cheap energy in the next 20 years. Actually, my forecast with Bob Metcalfe and people like Ray Kurzweil, we might have actually basically free energy in 30 years. And not only small amounts of energy, incredible amounts of energy, huge amounts of energy, 10 times more than what we have today, 100 times more energy than what we have today. And not only to stay here on planet Earth, but to go into space. We even have not only horsepower, we have also camel power today. We have different forms of energy that are being tested different places, and we will terraform planets. Once we leave our cradle, we will go into other planets. We will use Freeman Dyson spheres. And I want to say, as the Chinese, you know, they have all this fantastic wisdom. And because I have been living 3 years in Asia, they have this phrase, do not blame darkness, light up the world. And I'm moving to Korea, actually. I will be moving to Seoul soon. And you can see this is the Korean peninsula. North Korea is incredibly dark. South Korea is very, very illuminated. Seoul is one of the largest metropolises in the world, very illuminated. And remember, there is always the dark side of the force. So everything has yin and yang, and every yin-yang has more little yin-yang inside. So it's very complicated. So I'm moving to Korea. At Singularity University and International Space University, we had last year the first Korean astronaut. This year, we have the second Korean astronaut in our class. So we are very proud. Koreans are moving into space, and this will be the final frontier, going into space. But in the meantime, I want to be based on Earth, and I'm moving to new Songdo city, the most advanced city in the planet. If you think Dubai, Abu Dhabi, those were moderns, those cities were built by the South Koreans. And this is the city of the future that they are building now outside Seoul. So let there be light. Let's illuminate this planet. Let's meditate about the future. And I always meditate and I think about my Chinese. I'm learning Chinese. And, you know, before I wrote like that, now I write that like this or sometimes like that. But actually, it is like this. This is the Chinese or Japanese or Korean word for crisis. Crisis in Chinese has two parts. The first character means danger. The second character means opportunity. And the energy singularity is an incredible opportunity for humanity and post-humanity. So let's look at the bright side. Let's illuminate the world. Let's meditate. And thank you very much.
Do we have any questions? Really? You can do it this time, not even kidding. I'll allow it.
Are your slides available? Sure, and also I guess they are taping the whole presentation. Yes, and we have actually 5 minutes. I left 5 minutes for questions. We have one.
Yeah. Yes, what do you think it would take to wean companies like Raytheon and Lockheed Martin away from building war machines and convince them to build massive solar facilities on Earth and in space instead?
Yeah, the problem is obviously the lobbying groups. There are many interests. You know, ExxonMobil is the largest company in the USA, and obviously they have their interests. Also, other companies, Raytheon, they are working in different ways. So some political decisions have to be taken. But, you know, international competition will take these decisions because Japan is moving into space-based solar power. They had this $20 billion program to illuminate Tokyo by the year 2030. Also, China and India, they have also space programs to send astronauts or human-based operations to the moon that will make NASA also react in the USA. So I think international competition is beautiful. So they will have to learn one way or another.
So a question about your the part about solar energy. It's actually kind of two questions. My first is, you put up the map with the squares on it for what we would have to cover with current solar technology. Those squares were pretty big. One of them looked like it was covering most of Arizona, and while I have no problem with covering most of Arizona, I imagine people from Arizona might. So where are you going to find that space?
Well, actually, I put them over deserts so that people would not complain too much. But again, we will move also into space-based solar power, which is much better because the sunshine does not set on outer space, number one. Also, there is sunshine 24 hours on space. So we can do it on Earth because it is cheaper today, but later we will do it in space. Also, remember, we have nuclear fusion coming. Nuclear fusion is much more powerful than even solar power here received on Earth. So there is plenty of energy. And those squares were not that big. They were about 60 miles long. So 60 miles in Arizona is nothing.
And just a second question. By the way, I love solar power. Don't get me wrong. Production capacity, it seems as if the production capacity for stuff like solar panels is a little low right now. How would we ramp that up? Is that just a matter of political will? I'm all for it.
Well, again, there is technological change. I showed the equivalent of Moore's law for solar power. And this is changing really fast. There are already like 3 different programs to completely change fossil fuels for renewables in 20 years. This is possible. Even companies like Google actually, they are backing a proposal to forget about fossil fuels in 2030. This is possible. And I hope it will happen, and the sooner the better.
One more question, Jose?
Okay, quickly.
Sure. I don't mean to sound like too much of a naysayer when it comes to this, but there's when looking at even solar power, you're looking at the power grid today, we have a 15 to 30% loss in transmission, and you have huge infrastructural problems associated with this, not to mention the theoretical 83,000 or 100,000 terawatts is also encapsulating all of the energy that reaches the Earth entirely. So I'm sort of just wondering if it's not a bit of an oversimplification to just say we have enough energy, we can deal with it, also looking at global warming and carbon emissions as being a huge component of this.
Yeah, well, as I said, or Bob Metcalfe with the Enernet, the energy internet, we are going to move into more and more decentralized systems where electricity is locally produced, number one. Number two, when we move into space-based solar power, we will be able to beam down energy to the required centers. Like what the Japanese are doing, they want to start not in Tokyo, because people in Tokyo are afraid, of getting this beam of energy, which anyway will go into the Bay of Tokyo, will not go into the city center, but they are going to begin playing first in Okinawa, for those of you who know where Okinawa is. So it is not a problem, it is feasible. You could actually beam down energy to different distribution centers. But again, the point is that we are moving into decentralized systems, distributed energy.
Cool.
Thank you. Thank you.